At 3:45 in the afternoon on August 12, 2026, a column of molten rock shot 500 feet into the air above Hawaii. The plume above it climbed to 18,000 feet, higher than most commercial flights cruise over mountain ranges.
For decades, Hawaii's volcanoes have amazed visitors with their raw power. But what has just happened is capturing attention around the world for a very different reason. Deep beneath the island, forces that have shaped the landscape for centuries are now behaving in ways few expected. A remarkable new milestone has shattered a record that stood untouched for 40 years, leaving experts racing to understand what it means. Could this extraordinary event signal a major shift in volcanic activity? Or is something even more surprising unfolding beneath Hawaii's surface? Kilauea's record-breaking lava spectacle. What happened on August 12th was not simply another eruption. It was the latest chapter in a pattern that scientists had been watching unfold again and again, yet it still managed to capture attention across Hawaii and far beyond. To understand why this event mattered so much, you have to look beyond the towering lava fountains and focus on the remarkable rhythm the volcano has been following for months. Deep inside Halemaumau crater, at the summit of Kilauea, subtle changes were already underway long before the most dramatic scenes appeared. Around late morning, lava began spilling intermittently from the north vent, a location that has played a central role in the volcano's activity since late December 2024. The overflows were brief, but they were important. To the trained eyes of scientists at the Hawaiian Volcano Observatory, they were familiar warning signs that pressure was building beneath the surface once again. Using a network of instruments that constantly track ground movement, volcanic gases, earthquakes, and other changes, researchers watched as the summit continued to inflate. The volcano was effectively charging itself for another powerful release. Based on the behavior they had observed so many times before, experts anticipated that a much larger eruption was approaching. Their expectations proved correct. By mid-afternoon, the quiet overflows transformed into a full-scale eruption. Lava shot skyward from the north vent, climbing higher and higher within a short period. What began as impressive fountains soon became a spectacular display, with molten rock soaring hundreds of feet above the crater floor. Above the eruption, a massive volcanic plume expanded into the sky, rising thousands of feet over the island landscape. Strong winds carried volcanic gases, fine ash, and delicate strands of volcanic glass, known as Pele's hair, across parts of Hawaii Volcanoes National Park. Despite the dramatic visuals, officials confirmed that the activity remained confined within Halemaumau crater and posed no immediate threat to nearby communities. Even so, aviation alerts were elevated as the growing plume became a concern for aircraft operating in the region. What makes this eruption especially remarkable is not merely its size, but its place in a much larger story. Since December 23, 2024, Kilauea has been repeating an unusually consistent cycle. Eruptions burst from the north vent, the south vent, or both, often lasting less than half a day before suddenly stopping. Then, after a period of quiet buildup, the process begins again. The August event marked episode 53 of that sequence, extending a pattern unlike anything seen at the volcano in decades. Each eruption may appear unique when viewed on its own, but together they reveal a fascinating natural system operating with extraordinary consistency. For scientists, every new episode provides another piece of the puzzle. For everyone else, it serves as a powerful reminder that Kilauea remains one of the most closely watched and endlessly captivating volcanoes on Earth. Hawaii's volcano seems to follow a predictable cycle of fire and silence. Yet, something extraordinary is keeping this eruption alive far longer than expected. What hidden forces deep beneath the surface are fueling this relentless display? And why are scientists closely watching a pattern that has now repeated more than 50 times? Stay with us as we uncover the remarkable process driving one of nature's most astonishing spectacles. Hawaii volcano's unprecedented eruption cycle. Far beneath Hawaii's largest and most active volcano, an invisible process keeps resetting one of nature's most astonishing performances. Just when it appears the eruption has exhausted itself, the mountain quietly gathers strength again. Deep underground, fresh magma rises from Earth's mantle, refilling a shallow reservoir beneath the summit. Within days, or sometimes weeks, pressure builds once more, and the volcano returns to life in a dramatic burst of fire. What makes the current eruption so remarkable is not simply its power, but its persistence. Scientists have now watched the same pattern repeat more than 50 times. Lava fountains roar skyward, activity suddenly stops, and then the volcano slowly recharges before launching into another spectacular display. The cycle has become so consistent that researchers can track the mountain's breathing through sensitive instruments that measure the swelling and sinking of the summit. The scale of these eruptions has pushed Kilauea into territory never before seen in recorded history. In recent episodes, molten rock has been blasted thousands of feet into the air, reaching heights that surpass some of the most famous volcanic fountains ever documented on the island. To picture such a scene, imagine glowing lava being hurled higher than a skyscraper, driven upward by enormous gas pressure trapped within a rising column of magma. Yet the most fascinating part of the story lies in the records being broken. For decades, volcanologists looked back to an eruption that unfolded between 1983 and 1986 along Kilauea's East Rift Zone. That event became legendary, producing dozens of powerful lava fountaining episodes and transforming vast stretches of land. It stood as the benchmark against which all future eruptions would be measured. Then the current eruption arrived. By the middle of 2026, Kilauea had already matched the historic record in far less time than its predecessor required. Days later, it moved beyond that milestone, establishing a new standard for repeated eruptive episodes. With each additional fountain, the volcano continues extending a record that many experts once believed would stand for generations. The explanation begins deep within Earth. Kilauea sits directly above a mantle hotspot, a column of unusually hot rock rising from far below the planet's surface. Unlike volcanoes formed along tectonic plate boundaries, Hawaii's volcanoes owe their existence to this long-lived source of heat. As the Pacific Plate slowly drifts across it over millions of years, a chain of islands and underwater mountains is left behind. Hawaii occupies the youngest and most active position in that chain, standing directly above the hotspot today. Because of that unique location, Kilauea remains one of the world's most closely watched volcanoes. Every new eruption offers clues about how magma moves, how pressure accumulates, and how Earth's interior powers some of its most extraordinary displays. What scientists are witnessing now is more than another eruption. It is a rare opportunity to watch geological history being rewritten in real time. Kilauea's towering lava fountains capture the world's attention, but scientists say the volcano's most important story unfolds far beneath the surface. What hidden forces continue working even during periods of calm? And how could this vast underground system be shaping the volcano's next dramatic chapter? Let's find out. Kilauea's hidden underground. Lava engine. Deep beneath the summit of Kilauea, something remarkable is happening every second. Whether fiery lava is visible or the landscape appears completely calm. While many people focus on the dramatic fountains of molten rock that burst into the sky, scientists have discovered that the real story unfolds far below the surface, inside a vast underground system that rarely stops working. What appears to be a quiet pause is not a period of rest at all. Instead, molten rock continues rising from a powerful hotspot deep within the Earth, moving through a complex network of reservoirs and passageways hidden beneath the volcano. According to measurements from the United States Geological Survey's Hawaiian Volcano Observatory, the amount of magma entering Kilauea's system has been running about 25% higher than the volcano's long-term average. That may sound like a technical detail, but its impact is enormous. Imagine a block of glowing molten rock slightly taller than an average person being delivered into the volcano every single second. That process continues day and night, even when no eruption is visible. The volcano is constantly being refilled, quietly storing energy beneath the summit until the pressure reaches a critical point. This helps explain why the current eruption has followed such a rapid rhythm. The breaks between eruptive episodes have averaged only about 10 days, far shorter than the pauses seen during earlier eruptions. Rather than slowing down, the system replenishes itself at an extraordinary pace, allowing pressure to rebuild much faster than many scientists have observed in the past. Then comes the dramatic release. Once the underground reservoir reaches its limit, lava fountains suddenly erupt. Yet the ending can be just as startling as the beginning. Activity often shuts down almost instantly, as though someone flipped a switch. Within minutes, towering fountains can disappear, leaving behind an eerie stillness. But beneath that calm surface, the refilling process begins all over again. One of the most fascinating achievements of modern volcano science is the ability to anticipate these events before they happen. Around Kilauea's summit, sensitive instruments track tiny movements of the ground. As magma accumulates below, the surface slowly rises. By studying these subtle changes, scientists can estimate when another episode may occur. Before episode 53, for example, the summit had regained about 10 microradians of inflation after the previous activity ended on July 29th. Combined with ongoing measurements, this allowed experts to issue a forecast days in advance. Those predictions help park officials, emergency managers, and visitors prepare, turning one of nature's most powerful forces into a phenomenon that can be monitored with surprising accuracy. A volcano's fiery display can capture the world's attention, but what hidden changes beneath Kilauea have scientists watching more closely than ever? Why did one recent eruption behave so differently from others? And what could these shifting patterns reveal about the powerful forces moving deep below the crater's surface? Let's uncover the astonishing details. Kilauea's eruption. Mystery deepens. A towering column of fire shooting into the Hawaiian sky is always a breathtaking sight. But what happened during the latest activity at Kilauea has scientists paying close attention for reasons that go far beyond the spectacle. While many people focus on how high the lava fountains climb, researchers are studying something far more revealing: the volcano's constantly changing behavior. Each eruption episode seems to tell a different story hidden deep beneath the crater floor. Not long ago, one eruptive phase lasted only several hours, beginning on the evening of July 28th and ending in the early hours of July 29th. During that event, the north vent hurled lava nearly 500 feet into the air, while the south vent remained comparatively quiet, producing only flames near the end. The volcanic plume still climbed to nearly 19,000 feet above sea level, creating a dramatic scene across Hawaii's Big Island. Yet compared with earlier activity, the episode appeared restrained. A previous eruption had sent lava almost twice as high, revealing just how unpredictable Kilauea can be. This shifting intensity is more than a curiosity. Scientists believe it offers clues about the underground pathways that transport magma. Some eruptive cycles appear to drain larger portions of the magma reservoir, while others tap into gas-rich pockets that generate more powerful fountains. The contrasting behavior of the north and south vents further highlights the complicated network of channels hidden beneath the crater. At times, both vents erupt together. At other moments, one dominates, while the other barely participates. The danger extends far beyond the glowing lava. During active fountaining, volcanic material known as tephra is blasted into the atmosphere and carried by the wind. This can include fine volcanic ash, as well as delicate strands of volcanic glass called Pele's hair, which can travel surprisingly long distances. A striking example occurred in April 2026, when an earlier eruption produced fountains reaching about 800 feet, Lightweight volcanic glass fragments fell near Kilauea military camp, several kilometers from the vents, with some pieces measuring nearly a foot across. Accumulating debris even forced temporary closures of sections of Highway 11 and nearby viewing areas within the national park. As the current activity continues, wind direction remains a critical factor. Volcanic gases and airborne particles are being pushed toward the southwest, affecting communities downwind. Scientists from the Hawaiian Volcano Observatory and weather specialists track these movements continuously using satellites, computer models, and ground-based instruments. Their concern is not only falling debris, but also sulfur dioxide emissions, which react with moisture and sunlight to create the hazy volcanic smog known as VOG. For residents across the Big Island, the volcano's greatest threat may not be what erupts from the ground, but what lingers unseen in the air long afterward. Kilauea's relentless activity has already shattered expectations, but the most intriguing part may be what scientists still don't know. What is happening deep beneath Halema-Umayu crater? And how has months of powerful lava eruptions continued reshaping the landscape in ways few could have predicted? Let's unravel the details. Kilauea's endless lava transformation. Nobody can say exactly when it will stop. That simple truth has become one of the most fascinating parts of the ongoing activity at Kilauea's summit, where scientists continue watching a volcanic system that seems determined to keep rewriting expectations. While each dramatic burst of lava captures attention for a few hours or days, the larger story is unfolding much more slowly inside Halema-Umayu crater, where every episode leaves a lasting mark on the landscape. Far from nearby communities, the crater has been steadily transforming. Since late December of 2024, dozens of lava fountaining events have poured enormous amounts of molten rock onto the crater floor. What once appeared as a vast depression is gradually becoming shallower as layer upon layer of hardened lava accumulates. At the northern vent, a growing cone now stands significantly higher than before, altering the shape of the crater rim and providing visible proof of how much material has been added to the volcano over time. Yet the glowing lava is only part of the concern. During active eruptive periods, volcanic gases spread through the air, creating a haze known as VOG. Even many miles away, people can experience headaches, irritated eyes, and breathing difficulties. For those living with asthma, heart disease, or other respiratory conditions, the effects can be particularly serious. Health officials regularly encourage residents and visitors in affected areas to limit outdoor exposure and take precautions to avoid contamination from volcanic particles. What makes the situation especially intriguing is that, despite the impressive scale of the eruption, the lava has remained confined within the summit region. That has helped keep surrounding neighborhoods safe. Still, scientists are paying close attention because every new outpouring changes the crater's structure. If enough lava were to accumulate and eventually spill beyond the crater rim, the nature of the hazard could shift dramatically. Such an outcome is not expected at present, but it remains one of the many possibilities researchers carefully monitor. History offers another reason for caution. During the Pu'u'o eruption in the 1980s, volcanic behavior changed suddenly. A pattern of powerful lava fountains gave way to a new style of activity with continuous lava flows emerging from a different vent. The transformation happened quickly and with little warning, reminding scientists that volcanic systems can reorganize unexpectedly. For now, Kilauea continues its unusual rhythm. Between eruptive episodes, the summit slowly reinflates, suggesting that magma is still entering the system. As long as that supply remains strong, the cycle may continue. Whether it lasts weeks, months, or longer remains unknown. And perhaps that uncertainty is what keeps the world watching. Because beneath the surface, the volcano is still deciding what comes next. Something extraordinary is happening at Kilauea, leaving even veteran scientists searching for answers. But what has made this eruption unlike anything in Hawaiian history? And why are experts watching every move of this restless volcano so closely? Could its next chapter be even more remarkable than what has already stunned the world? Let's find out. Kilauea shatters historic eruption record. Something remarkable is unfolding at Kilauea, and even the scientists watching it around the clock cannot say exactly what comes next. The eruption could suddenly quiet down, shift into a completely different pattern, or continue its dramatic cycle for months, perhaps even years. The instruments scattered across Hawaii will reveal the change when it happens, but they cannot yet tell which future awaits this restless volcano. What they do know is extraordinary. In less than 2 years, Kilauea has produced more separate lava fountaining episodes from a single eruption than any other eruption recorded in Hawaiian history. Episode 53 now stands as the newest chapter in a story that continues to surprise even those who study volcanoes for a living. Yet statistics alone fail to capture the reality of what visitors witness from the distant viewing areas. Deep inside Halemaumau crater, a vast pit nested within the larger summit caldera, molten rock surges upward in brilliant shades of orange and red. The active area remains closed to the public, and for good reason. Cracked ground, unstable crater walls, falling rocks, and shifting rim sections create constant danger. Since 2007, access around the crater edge has remained restricted. From safe overlooks, however, the scene is unforgettable. A towering fountain of lava can rise from the crater floor and stretch high into the sky, feeding a massive plume of gas and ash that drifts across the tropical landscape. Against the deep blue backdrop of the Pacific sky, the eruption looks almost unreal. The ground vibrates gently beneath observers' feet, carrying the energy of the volcano through the earth. Moments later comes a distant roar, low and powerful, like nature speaking in a language older than humanity itself. One of the most fascinating aspects is that these eruptions rarely arrive without warning. Before each episode, instruments detect tiny swelling movements in the ground, sometimes measuring changes no larger than a few millimeters. Those subtle signals reveal pressure building beneath the surface. Thanks to decades of scientific work and an increasingly sophisticated monitoring network, experts can often announce an approaching episode before the first lava fountain appears. Sometimes only hours separate the moment lava begins overflowing from a vent and the instant enormous fountains surge skyward. When conditions are just right, the volcano creates another spectacle. Thin strands of volcanic glass, known as Pele's hair, drift through the air like glowing threads of copper carried by the trade winds before cooling and settling across the landscape. For now, the eruption continues. The cameras remain fixed on the crater, the instruments never stop recording, and episode 53 remains alive. Another astonishing reminder that Kilauea is still writing history in real time. Thousands are watching Hawaii's volcano around the clock, captivated by a display of nature's raw power. But what makes this eruption so extraordinary? Why are scientists paying such close attention? And could the records it's breaking reveal something even more significant about what comes next? Let's uncover the intriguing details. Hawaii volcano draws global attention. Across the big island of Hawaii, an extraordinary spectacle continues to unfold. Day and night, thousands of people keep their eyes fixed on glowing streams of lava through a network of live cameras aimed directly at the summit. Some viewers are curious travelers, others are scientists, and many are simply fascinated by the sight of a volcano revealing its power in real time. During the most dramatic eruptive phases, the audience swells into the tens of thousands, transforming this eruption into one of the most closely observed volcanic events the world has ever seen. What makes this eruption so remarkable is not only its intensity, but also how accessible it has become. Unlike earlier volcanic activity that occurred in remote sections of Hawaii's rift zones, far from established viewing areas, this eruption is taking place within one of the most visited national parks in the United States. Visitors can stand at designated locations and witness nature's raw energy, while people on the other side of the planet watch the same event through live broadcasts. Yet the glowing fountains and rivers of lava tell only part of the story. Beyond the breathtaking images lies a constantly changing environment shaped by volcanic gases. During major eruptive episodes, sulfur dioxide emissions surge dramatically, spreading through the atmosphere and reacting with sunlight and moisture. Within hours, shifting winds can redirect volcanic haze, known as VOG, across entire communities. Residents in areas southwest of the summit, including Ocean View, Pahala, and Nalehu, often find themselves monitoring air quality as carefully as scientists monitor the volcano itself. As winds carry gases and ash across the landscape, local authorities work closely with volcanologists and weather experts to provide timely warnings. Families are encouraged to remain indoors when conditions worsen, keep windows closed, use air filtration when possible, and limit strenuous outdoor activity. For many residents, living near an active volcano means balancing awe with caution. Meanwhile, the mountain remains under constant surveillance. An extensive network of instruments measures every movement beneath the surface. Tilt meters detect subtle swelling of the ground. Seismometers record earthquakes deep below the crater. GPS stations track tiny shifts in the landscape, while satellites, gas sensors, and webcams provide an uninterrupted stream of information. By analyzing these signals, scientists can often anticipate a new eruptive phase days before lava appears. By August 2026, the volcano had already produced more than 50 eruptive episodes in less than 2 years, fueled by a mantle hotspot delivering magma at an unusually high rate. It continues to reshape the summit crater with each outburst. Yet, despite all the technology surrounding it, the volcano remains true to its ancient rhythm. Long before people arrived on these islands, it was building land, filling craters, and sending volcanic glass into the winds. Today, it continues that timeless work while the world watches. Episode 53 may seem like the latest chapter in an extraordinary story, but the real mystery lies in how we can now witness nature's raw power almost as it happens. What makes this eruption different from countless others before it? And how are scientists tracking every subtle sign of what could come next? Let's unravel the details. Kilauea's new era of observation. Episode 53 is only the newest chapter in a story that has been unfolding for far longer than any human record can fully capture. High above Hawaii, where molten rock bursts into the sky and glowing lava reshapes the land, a powerful cycle continues, much as it has for countless generations. Yet what makes this moment different is not the volcano itself, but the extraordinary ability of people to watch it unfold almost in real time. Across the slopes and summit of Kilauea, a network of instruments quietly tracks every subtle movement. Tilt meters notice the slightest swelling of the ground. Sensors detect changes hidden deep beneath the surface. Together, they reveal patterns that would have remained invisible only a few decades ago. The volcano does not obey these machines, but the machines have given people a clearer window into its behavior than ever before. Even as spectators focus on the dramatic fountains of lava and the glowing vent at Halemaumau, scientists are already looking ahead. The same signals that helped explain Episode 53 are beginning to hint at what may come next. Pressure slowly gathers beneath the summit, and every measurement adds another clue to a process that never truly stops. Yet science tells only part of the story. For many people on the Big Island, Kilauea is far more than a geological feature. Long before modern monitoring systems appeared, Hawaiian traditions described the volcano as the home of Pele, whose presence is expressed through both creation and destruction. In this view, the fiery displays are not simply natural events recorded on computer screens, but part of a much deeper relationship between the land and the people who live upon it. That connection can still be seen in the names given to volcanic phenomena. Pele's hair, the delicate strands of volcanic glass carried by the wind, reflects centuries of observation and understanding, passed down through generations. It is a reminder that while modern technology can measure the volcano with remarkable precision, the human bond with this landscape reaches back much further, linking today's eruption to a history that stretches across time itself. The volcano's latest eruption painted Hawaii's skies with shimmering volcanic glass, leaving scientists and local communities seeing the same event through very different lenses. But what do these glowing strands truly reveal about the mountain's growing unrest? And why is the massive plume rising above the crater drawing such intense attention from experts and residents alike? Let's find out. Volcanic glass drifts across Hawaii. When episode 53 pushed shimmering strands of volcanic glass across the Hawaiian skies, carried southwest by the steady trade winds, it created a scene that felt almost unreal. To scientists, those drifting threads were another sign of an active eruption being measured, mapped, and analyzed. To many local communities, however, the volcano's behavior carried meanings rooted in generations of observation and cultural understanding. These different ways of seeing the same event often exist side by side, shaping how people interpret and respond to the mountain's restless activity. Far above the crater, a towering plume climbed nearly 18,000 feet into the sky, while below, brilliant lava fountains surged as high as 500 feet above the crater floor. It was one of the most remarkable natural displays on Earth during the summer of 2026. Yet despite the dramatic images shared around the world, witnessing such an event in person is far from simple. Many travelers arrive at Hawaii Volcanoes National Park hoping to experience the eruption at its peak. Some are lucky enough to find lava already bursting from the vents. Others spend days waiting, only to discover that the volcano has fallen quiet again. Since December 2024, most eruptive episodes have lasted less than 12 hours, and some have ended even sooner. The volcano follows no schedule and offers no guarantees. Scientists from the Hawaiian Volcano Observatory can often identify signs that an eruption is approaching and provide forecasts several days in advance. As activity increases, those forecasts become more precise. Even so, the exact moment when lava will erupt remains uncertain until the final warning signals appear. The forces beneath the ground operate according to pressure and geology, not human plans. Conditions can also change dramatically from one episode to the next. During episode 53, volcanic gas and tiny glass fragments drifted southwest. Under different winds, future eruptions could send them toward other communities around the summit. Viewing areas that are open one day may be closed the next because of changing hazards. Every shift in wind, gas, and volcanic activity creates a new situation. Behind the scenes, an extensive monitoring network tracks every tremor, tilt change, and gas measurement in real time. Together, these instruments tell the ongoing story of a volcano that remains impossible to control, endlessly fascinating, and determined to move only according to its own rhythm. So, what do you think caused Hawaii's volcano to shatter a record that stood for over 40 years? And why are scientists monitoring it so closely? We'd like to hear your thoughts. Don't forget to like and subscribe.